Hey guys, I hope you are doing well. Today we'll be talking about bias and variance and how exactly it's used in ML model. So let's take an example which is a bit funny, but just to remember. So this is the hours you put in: two, three, four, five. This is the hours you put in what? Playing games. And by doing so, the damage in your eyes will be also high. So if you play a game for 2 hours, there'll be, let's say, 20% damage. There'll be, let's say, 30% damage. There will, let's say, 40% damage. There'll be 50%. You don't take 100%, right? Okay, fine. So let's say we collected a data set of it, or a random data set. I'm not gonna measure it in plot. Okay. So let's say this is a data set. And what will be an ideal data set for this? Let's say it's somewhere like this. Somewhat like this. Yeah. Oh my god, okay. Somewhat like this. Okay. So before we begin, I would like to tell you a thing, which is one concept you must remember, where whenever there's low bias and whenever there's high variance, it's always a overfitting model. Overfitting. And whenever we take low bias and low variance, then it's a ideal model, which is not ideal, but we can say generalized model. This is the right term. Generalized model, right? So why exactly this happens? Why exactly whenever there's low bias, high variance, why overfitting? And whenever low bias, low variance, why it is generalized? So today we'll be talking about that, and that's the whole main point of the video. So let's get started. I'll just clear this up real quick. So let's take this particular data set, and let's say we are training this first. So these are my training points, and let's say I used a linear regression model, which is like this. Okay, and on the other hand, let's say these are the training data points, which is gonna be the same. We get a curly kind of curve. So something like this. Alright. Something like this. I might have messed it up. Okay. Fine. So these are the same data points, which is training, and here it's just a linear regression model. You can say that it's not really it's not really like combined with the training data set, but here in this case it's perfectly going through it, right? So we can say that this guy this guy has low bias, this guy is high bias. What is bias? Let me write the definition of bias, which is nothing but uh, the inability of ML model or ML algorithm to fit the data points. So the inability here of a ML model to fit the data point is high, and whereas here it's low, right? So this is about bias, and understand this. Why is it? Why is it that There is, if you still didn't get, in case there's high bias here, there's low bias here. So let me tell you again that the inability of a model algo to fit the data points. The inability here, it's not even touching a one data point, right? So the inability is higher, right? So high bias. It's not even matching a data point. Yeah, see, it's easy, right? High bias. Whereas here, it's literally going through it like exactly like how exactly it should be, right? So it is low bias. So I hope you understood about bias, and let's dive into variance, right? So yeah. So let's say we are now testing the same data set, and this one, this particular model, the data should be a bit different, I would say. Okay. So in this case, I'll again take a random data, and in the case of a linear regression model, let's say it's somewhat like this. In this is in the case of test data, right? Testing the data, testing it, testing it. And yeah, in the other case, you'll be shocked to know that some might not, that it's overfitting. Overfitting in the sense the the data which we trained on, it's exactly the same. It's exactly the same curve, but this time the points are different. The points are different. So you can see that there's some distance from the linear regression, which is the line. I mean, so the variance here is much more higher than the variance here. That means that this has low variance, whereas this has high variance. High variance. It's really varying from the original curve or original ML model. So if you really think from a different point of angle, like if you really train a data set and if it's perfectly matching, then it is overfitting, and this will be nothing. Okay, so you must have understood that this this is high variance, this is low variance. Okay, and if I tell you the variance definition, so that will be how far is it? How far are the test data points? Right. So this guy had low bias and high variance. So that means this is overfitting in this case. So that's it. That's it. That's what I wanted to tell in this video. And I hope I solved your doubt. And see you in the next one. Bye.